Multiple choice questions. Question 1. The rate expression for the reaction between x and y is. So that is the rate equation. Which statement is correct? The rate constant has units mol to the power minus 1 dm cubed s to the power minus 1. Now before I even do the calculation required to do that, it's not too difficult. I am exaggerating a bit. I can eliminate D because the rate constant is independent of temperatures. Kc, Kp, constant is always dependent of temperature. It always depends on temperature. If the temperature increases, what will happen? So the idea that the rate constant is independent of temperature, that statement is false. So it can't be correct. So now we're left with A, B, and C. A, well, let's work that out. So K, rate constant K, equals rate mol per dm minus cubed s to the power minus 1. Is it mol per dm cubed s to the power minus 1? Yeah, I think mol per dm cubed divided by... Actually, let's look at B and C. And then if B and C, because B and C are just like wordy questions, it's not a requirement to calculate that. B, the rate of reaction is halved if the concentration of X is halved and the concentration of Y is double. So let's think about it. Rate of reaction is halved if the concentration of X is halved. So we have a half squared times Y and the concentration of Y is doubled. What will happen? Well, a half times by half is a quarter and times by 2 is a half. So the reaction will in fact be halved. So the answer is B. If I look at C, the rate increases by a factor of 16 if the concentration of X is tripled. Well, if that's the case, then it'll be 3 squared times by, and the concentration of Y is doubled, times by 2. And I've put that in the calculator. I don't need to. 3 squared is 9. 9 times by 2 is 18. So the rate will actually increase by a factor of 18. So that's false. So the answer is B. Question 2. What are the units of rate constant for a third order reaction? So let's just, construct the rate expression. Rate equals K, third order reaction, Y to the power 3. Third order. Now to find out the units, well, we do K equals mol per dm minus cubed s to the power 1 all over mol per dm minus cubed to the power of 3, because cubed. And what we can notice is that that'll cancel out, and now we're left with K equals s to the power minus 1 all over mol per dm minus cubed squared, and that is the same as s to the power minus 1 over mol to the power 2 dm to the power minus 6. And now because we want it in this kind of format, not as a fraction, well, then that's going to be s to the power minus 1 mol to the power minus 2 dm to the power 6, because these mol to the power of 2 dm to the power minus 6 is the denominator, so we have to do the opposite. So since this is 2, it's going to be negative. Since it's minus 6, that's going to be negative, but it's going to be negative, negative, so therefore it's going to be positive. So whichever one fits this. Mol to the power minus 2, dm to the power 6, s to the power minus 1. So the answer is D. Question 3. The results of an investigation of the reaction between P and Q are shown in this table. The rate equation is that. What is the initial concentration of Q in experiment 2? Okay, so experiment 2 is clearly this one. We want to find the initial concentration of Q. Now, we know that the initial rate goes from 0.400 to 0.800, so it's doubled the rate. Initial concentration of P, well, 0.600 divided by 0.200, we times it by 3. So therefore this, in order to get a total rate of reaction to double, this has to be 3 times by 3 over 2. No, 3 times by 2 over 3. This has to be 2 over 3. We're timesing by 2 over 3. But that is but we can see clearly that that is second order, so that's squared. So if we want the initial concentration of Q, what we have to do is have to square root this, because remember Q is squared, and we want to find the initial concentration of Q. So what we have to do is square root our answer. So we have to do 0.500 times by the square root of 2/3, and I get 0.408, and then it keeps going, so the answer is C. Now that's a nice little trick, that hopefully you guys spotted, and if you didn't, hopefully you learned from it. But because it's the power of second order, we have to square root it, and then obviously times the initial concentration by the square root of 2/3 to get the initial concentration of Q as 0.408 in experiment 2. Now I'm marking it. So question 1B, perfect. Question 2D, perfect. Question 3C, perfect. And that is the end of the multiple choice question.